Remember how we had in linear functions the expression y equals mx plus b, and b represented the cut with the y-axis? Well, in quadratic equations we are going to have that as well, and that's going to be represented by the c, which is a constant. Okay, so let's make a little example following our previous video. Let's say we have y equals x squared plus 2. What does the 2 mean? Well, it just said it's going to cut the y-axis in 2. That is correct. We count 1 and 2, and right there is going to be the cut with the y-axis. And that makes sense, because if x is 0, then y is 2. So there you go. The function is the same, only that it's moving north 2 spaces. Okay? Let's make another example. What happens if we have y equals, let's say, the same that we had in the past video, 2x squared plus 3. Remember, 2x squared, now we're adding 3. What does that mean? The cut with the y-axis is going to be located 3 spaces above. So we count 1, 2, 3, right here. And the function, because it has 2, which means the a is higher, the function is going to be closer. The concavity is going to be closer, okay, than x squared. So it's going to look a little bit like this. Okay? But what happens if we were to graph x squared plus 3? Where would that be? Well, let's do that again. X squared plus 3 is pretty similar to x squared plus 2. The only difference is that the cut with the y-axis is going to be located at 3, right here. The concavity is not going to be as aggressive as 2x squared. It's going to be similar to x squared. And there you go. Alright, now, what happens if a is negative? Well, same deal. Let's say minus x squared plus 2. Remember what we said about a in our previous video? If a is negative, the concavity is going to be down, down, down. Okay? So, a is minus 1, the cut with the y-axis is located at 2, so it's right here. But the concavity is going to be down, okay, because it's minus 1. So the function is going to be this. Okay? What happens if we have y equals, let's say, minus x squared minus 4. See, another variation of the same basic example, minus x squared. The cut with the y-axis is going to be located at minus 4. Minus 1, minus 2, minus 3, minus 4. Concavity is going to be down because it's negative 1. The graph looks like this. Y equals minus x squared minus 4. What happens if we have y equals minus 2x squared minus 4? Cut with the y-axis stays the same at minus 4, but the concavity not only is negative, but it's closer. Okay? Therefore, the function is going to look a little bit like this. Okay? Y equals minus 2x squared minus 4. And there you go. As you can see, A and C are very important in quadratic equations because you are able to determine the degree of convexity that the function has, how wide it opens, up north or down